Okay, so back again, more matrices. So we're on to question 4 now. So this is matrices question 4. I've got the questions by the side here. Calculate the determinants of the following matrices. So A, calculate the determinant of 2, 1, 3, 4. And the way to do this, it's 2 times 4 minus 1 times 3, which is 5. B, the determinant of 1, 3, minus 2, minus 1. So it's 1 times minus 1, minus 3 times minus 2. So it's minus 1 plus 6, which is 5. C, got the determinant of 1, 4, 0, 1. So this is going to be 1 times 1 minus 4 times nothing, which is 1. D, determinant of 7, 6, minus 6, minus 5. So it's 7 times minus 5, minus 6 times minus 6. So that's minus 35 plus 36, so that's 1. E, 3 by 3 now. Oh, it'll be a second. Just getting a bit warmer here. Right, a 3 by 3 E. Determinant of 1, 3, 2, 2, 0, 1, 3, 1, 0 equals, so it's 1 times 0, 1, 1, 0. Okay, so imagine it's that number and you imagine crossing out that column and that row, so it's just that little bit there. Next one, it's always minus 2. And it's times the determinant of that one. Times the determinant of, so it's crossed out with the 2. Row in the column with the 2, it leaves the 3 and the 2 and the 1 and the 0. 3, 2, 1, 0. And then it's plus 3 times 3, oops. So the last one, just going to show you here. So imagine crossing that out, and you're left with that block there. 3, 0, 2, 1. 3, 0, 2, 1. So it's 1. And then it's 0 times 0 minus 1 times 1. Minus 2. 3 times 0 minus 2 times 1. And then plus 3. 3 times 1 minus 2 times 0. Okay, so I'll just point out where they come from. 1, so that the number in front of the bracket is always this bit here. And then it's that leading diagonal, 0 times 0, look, 3 times 0, 3 times 1, and then it's always minus. And then it's the other diagonal, 1 times 1 for that one, 2 times 1 for that one, 2 times 0 for that one. So it's equals 1 times minus 1, minus 2 times minus 2, plus 3 times 3, I believe. Some usual numbers. Anyway, so it's minus 1 plus 4 plus 9, which is 12. So I've done E, F next. 2 minus 4, 1. Minus 1, 2, 6. 1 minus 2, 7. Okay, so 2, 2, 6, minus 2, 7, minus 1, minus 4, 1, minus 2, 7, plus 1 times minus 4, 2, 1, 6. So it's going to be 2 times 7 minus 6 times minus 2, plus 1, minus 4 times 7 minus 1 times minus 2, plus 1, minus 4 times 6 minus 1 times 2. And then that's 2, 14, plus 12, 26, plus 1, and then that's minus 28 plus 2. 1 times minus 26, and then plus 1 times minus 24, minus 2, minus 26, so that's going to be 0. Okay. And then the last one. Right, you can see that that one would come up as 0 if we'd have spotted already that this row is minus 2 times this row. So what if one row is a direct multiple of the other? It comes up as 0. I think. I'm not completely sure about that off the top of my head actually. I'm just leave it. I'll just work it out. If it comes up as 0, it comes up as 0. I can't quite remember the actual wording of the way to word it, so I'm not going to give you any rules there, but just work it out. Right, G now. Oh, I did have them already written up. I thought I would do. Right, G's written down here. Brilliant. G, so the determinant of this is 3 minus 1, 0, 2, 3, minus 1, 2, 5, 2, 3, plus 4, 2, minus 1, 5, 0. This is 3 minus 1 times 3, minus 0 times 2, minus 1, 2 times 3, minus 5 times 2, plus 4, 2 times 0, minus 5 times minus 1. So this is 3, and it's going to be minus 3 inside that bracket because of that 0, minus 1, and then this is 6 minus 10, so it's minus 4, and this is going to be 4 times 5. So it's minus 9 plus 24, which is 15. Okay, and these are all done previous page. There we are. Yeah, they're all there. Okay, right, so number 5. So I don't need that anymore. Right, use determinant properties to find the values of the following determinants without expansion. Okay, so for A, what we can say, if we do row 2 becomes the old row 2 minus row 1, and if row 3 becomes the old row 3 plus 3 row 1s, what this actually becomes, 1 stays as it is, and then for the next row, look, the new row 2, I suppose some people put like a little star there for the new row 2 with the new row 3. The new row 2 is the old row 2 minus row 1, so it's that, take away that. 1 take away 1 is 0, minus 1 take away 2, minus 3. 3 take away 5 is minus 2. And then the new row 3 is the old row 3 plus 3 row 1s. So we've got minus 3 plus 3, 6 plus 6, and then 1 plus 15. There's going to be answers there. So that's going to be a 0, that's going to be a 12, and that's going to be 1 plus 15 is 16. Okay, now the reason why I chose these here, because I wanted a 0 there and I wanted a 0 there, and because I've got a 1 there, so I've used that 1 to make zeros there and there with these expressions here. So then we can say the determinant of 1, 0, 0, 2 minus 3, 12, 5 minus 2, 16. You can jump straight in here. You can just say it's 1 times the determinant minus 3, 12, minus 2, 16. Because those zeros there are 2 zeros in any of these positions, so there's fine. Means that all the other bits are going to be 0. So you just need, if you can get a 0 like this, you've just got that 1 there to work out. If you try it putting the others in, you'll just see you get lots of zeros. So it's minus 3 times 16 minus 12 times minus 2. So it's 1 times minus 48 plus 24, which is minus 24. So B, same thing for B. Right, so we've got a 1 there, we've got a 0 there, so we're just going to change this one to get a 0 here. So we're going to do row 3 star, new row 3 is the old row 3 minus 3 row 1. Okay, and the other two can stay as they are. So then we've got 3 minus 3 is 0, minus 6 minus 6 minus 12, minus 1 minus 15 minus 16. And then the determinant of this is 1 times 3 times minus 16 minus 12 times 2. So it's minus 48 plus 24, which is minus 24 again. And then C. Same again for C, got similar numbers. The new row 2 is going to be the old row 2 minus 3 row 1, and the new row 3 is going to be the original row 3 plus row 1. Okay, so the top row stays as it is. 3 minus 3, 0, minus 6, minus 6, minus 12, minus 1, minus 15, minus 16. And the next one, minus 1 plus 1 is 0, 1 plus 2 is 3, minus 3 plus 5 is 2. So it's going to be 1 times minus 12 times 2 minus 3 times minus 16. So it's 1 times minus 24 plus 48, it's actually plus 24. I'm seeing the connection of all these numbers here. We'll go back and have a little look at that in a minute. So to go from the, what's happening here? There's a big connection here with these numbers. I'm getting the same numbers over and over again. Anyway, I'm just working out the determinants. The last one, with top row's fine. The second row, we'll do row 2, the new row 2 becomes the old row 2 minus 2 row 1, and the new row 3 can become the old row 3 minus 5 row 1. I want the determinant of that. So 2 minus 2 is 0, minus 1 minus 2 minus 3, 6 minus 6 is 12. 5 minus 5 is 0, 3 minus 5 minus 2, 1 minus 15 is actually 16. Same numbers again. 1 times minus 3 times 16 minus 2 times 12. 1 times my minus 48 plus 48, which is not. Anyway, you can check these on your calculator if you've got a calculator that will work them out. Right, number 6. Find the inverse of the following matrices. So the det of 3, 4 determinant, that is 3, 2, 4, 3. 3 times 3 minus 4 times 2, which is 9 minus 8, which is 1. So the inverse is 1 over 1, so it's 1 over the determinant. And then you swap these two round, so it's still going to be 3 and 3, and you multiply the other two by minus 1. So it's going to be 3 minus 4 minus 2, 3. B, the determinant of 6 minus 1, 3, 2. 6 times 2 minus 1 times 3. So it's 12 plus 3, which is 15. The inverse is 1 over 15. Swap the first two. Change the sign of the others. And that will do as an answer there. C, the determinant of this, 2 minus 1, 1, 2. So it's 2 times 2 minus 1 times 1. So it's 4 plus 1, which is 5. And the inverse is 1 over 5. Swap the leading diagonal, change the sign on the other. and then the last one, D. Right, the determinant of cos theta sine theta minus sine theta cos theta. So it's cos theta times cos theta minus sine theta times minus sine theta. So that's actually cos squared theta plus sine squared theta, which is 1. So the inverse for this one is 1 over 1. Swap the first two. Change the sign of the other ones. And that's all it is. So it's cos theta minus sine theta cos theta. Okay. Next one, number 7. Find where possible the inverses of the following matrices. Right, so for these, there's quite a process involved with these, so I'm going to need a bit more room, I think. Anyway, A, you always got to start by doing the determinant of each one. Okay, so the first one, remember we've got these 2 zeros here, so we can just go straight in. It'll be 1, 1, 1, 0, 1. So it's 1 times 1 minus 0, so it's 1. I wonder if I can get the determinants of each underneath here like this. The B, determinant of Q, it's always the first step. Step 1 is the determinant. The ones where it says if possible, so if the determinant comes up as 0, then it's not possible. So this is going to be 1, minus 1, 1, 1, 2. Then minus 2 times the determinant of 2, 3, 1, 2. And then plus 1 times the determinant of 2, 3, minus 1, 1. I'd normally do that in a long line, but I'm going to run out of room here. So therefore, det Q, determinant of Q, I'm going to do some of this in my head. So it's minus 2 minus 1, which is minus 3. And then the next one, so it's 4 minus 3, which is 1. And then you've got minus 2 times 1. Minus 2 times 1, minus 2. And then the next one, it's plus 1, and it's 2 minus 3, so it's 5. No, so that's the end of that one. Can't, doesn't have no inverse is the answer for that one. Okay. And let's do C, the determinant of R. So it's 1 times minus 1, 1, 1 minus 2. Minus 2, 2, 3, 1 minus 2. Plus 1, 2, 3, minus 1, 1. Det R. So I'm going to do this here. So it's 1, and that's 2 minus 1, which is 1. So it's 1 times 1, which is 1. And the next one, minus 2. So this is minus 4, minus 3, minus 7, times minus 2 is plus 14. And then the last one, 2 minus 3. So it's 2 plus 3, which is 5. So it's plus 5. So det R is 20. Okay. So that stage we can work out determinants for A and C. So the next thing you need to do is what's called matrix of minors. This is step 2. Okay, so what we do here, you have, I'm not going to, this one we don't need to do, so So I'll just do this one. So this one's A and this one's C. Right, so this one's a bit fiddly. For this top corner here, imagine crossing that out and that out. So you're left with those 4 there. And you do that determinant, so it's 1 times 1 minus 0 times 1. I don't know if to do this a little bit bigger, actually. Or I might be able to fit it in here. So this is the determinant of, just a determinant sign, 1, 0, 1, 1. Okay, and then the one next to it there, so we cross out that one and that one, so it's 0, 0, 1, 1. And then in the top right hand corner here, cross out these, so we've got 0, 0, 1, 0. They get crossed out. 0, 0, 1, 0. So the next row, so we cross out, always cross out that one for the next row. So I could just cross that out now like that. Okay. So the first one, cross out that. So it's 1, 1, 0, 1. Let's just put these lines in here. So the first one is 1, 1, 0, 1, 1, 1, 0, 1. So for the second one, imagine crossing that out. So we've got 1, 1, 0, 1. That was the same as the previous one. 1, 1, 0, 1, 1, 1, 0, 1. Yep, that's correct. And then for the last one, 1, 1, 0, 0. Because we cross out, yeah, 1, 1, 0, 0. Right, so about that pink. Ah dear, just rub out the pink. Rub out the pink. Should be easy. Let's do that there like that. Right, so in the bottom left, so now we've always crossed out the bottom row because we're on the bottom here. And then the first one, we cross out these two, so it's 1, 1, 1, 1. For the second one, we cross out the second column, 1, 0, 1, 1. And for the third one, cross out the third column, so we've got 1, 1, 0, 1. 1, 1, 0, 1. So this is, right, zeros are good. Well, they simplify things quickly, so it means that's 0, that one's all 0, they're all zeros, they're all zeros, that's a 0. Every time there's a 0 in one of the diagonals, then that's a 0, so it's easy. So this top one is 1 times 1 minus 0. This one is 0 and 0, so that one's 0. And the next one, look, 0 minus 0 is 0. So the next one, next column, 1 times 1, and then there's a 0, so we don't need to go any further with that one. Same with the next one, it's a 1. And then the last one there is a 0. It's completely 0 because each diagonal multiplies to make 0. This one's a 0, not because of 2 zeros, because of 1 times 1 minus 1 times 1. This one, that's a 1. I've already done that one above, that matches the one above. And so is that one there. Okay, so that's the matrix of minors. I'll come back and do C in a minute. So then step 3, you do the matrix of cofactors. And the difference here is you change the sign of these ones here. Okay, that's what you do in this step. It's not really equals actually, because they're not equals to each other, it's just what they are. So this is going to be 1 minus 1, 0. Can't change the sign of nothing. 1, that changes the sign there. 0, can't change the sign of 0, and that one stays the same. So all the pink blobs have changed sign. And then step 4, So you get the, you take the transpose. You take the transpose of what we've just done and multiply by 1 over the determinant. Okay, so, and that's the actual inverse. So at this stage we can say P inverse equals 1 over 1 for 1 over the determinant, and we take the transpose, so that means the column here becomes this row, so that becomes the second row, and that becomes the third row. So it's going to be 1 minus 1 0, 0, 1 minus 1 0, 0, 1. Okay, and that's that one. The way to check it, I'll do the check up here. The check for the first one for A is, so you take the original 1 0 0, 1 1 0, 1 1 1, multiply by the determinant, the inverse, 1 0 0, minus 1 1 0, 0 minus 1 1. And then you do row, column, you do each of these first of all. So it's 1 plus nothing, minus 1 plus nothing, 0 minus 1 plus 1. And then we move on to the second row with each of these. So it's 0, 0, 0. The next one is 0, 1, 0. And the last one is 0 minus 1 plus 1. And then we do the third row with each of these. So it's 0, 0, 0, 0 plus 0 plus 0, 0 plus 0 plus 1. It comes out as the identity. There's every chance we've got it right. Unless we've made 2 mistakes that counteract each other, but it's very unlikely. Right, C. So again, we're going to start with these. Matrix of minus. Okay, I'm going to set up these exactly the same as I did before. So I won't go through all the, because I've already done this. Minus 1, 1, 1, minus 2. Next one, 2, 3, 1, minus 2. And the last one, 2, 3, minus 1, 1. Next row, cross out that one and that one, 2, 1, 1, minus 2. In the middle, 1, 3. So I'm doing exactly the same as I did in the previous one there, so I don't really want to spend a lot of time doing this. 1, 2, 3, 1. This corner, 2, 1, minus 1, 1. This one, 1, 1, 2, 1. And then this last one, 1, 2, 2, minus 1. Okay, so I'm going to work each of these out. So this is going to be 2 minus 1. This one is minus 2 minus 3. 2 plus 3 is 5. Minus 2 minus 1 minus 3. Minus 2 minus 3. 1 minus 6. Next one, 2 plus 1. 1 minus 2. Minus 1 minus 4. I'm just going to check that because some of these I can't quite read my own writing. 2 minus 1, checked. Minus 4 minus 3. 2 plus 3. Minus 4. This one. Minus 4 minus 1. I'm glad I checked that. That was the one actually that made me think I need to check that one. So it's minus 4 minus 1 is minus 5. I'll keep checking the others. Minus 2 minus 3. 1 minus 6 is minus 5. This one, 2 plus 1 is 3. 1 minus 2 minus 1 minus 4. Good. Got that answer there. So now I want my pink blob to show you which ones change the sign. There, 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 and there. I change the sign. This forms the matrix of cofactors. Plus 5, 3, 7, minus 5, plus 1, 5, 5, minus 5. So step 4, we take the transpose of this. 1, 5, 3. So the rows and the columns swap. 7 minus 5, 1. 5, 5, minus 5. I multiply by 1 over the determinant. I'm just going to do a quick check of this. Now, I wouldn't recommend checking in the exam unless you've got time. I'm just going to check with the check now. So the original was 1, 2, R inverse is what we call this, because it was R to start with. 1, 2, 3, 2 minus 1, 1, 1, minus 2. 1, 7, 5, 5, minus 5, 5, 3, 1, minus 5. So 1 plus 14, 15, 20. I want 20s on the leading diagonal because I've got this 1 over 20 here. So basically I want 20s there and 0s everywhere else. So underneath, 2 minus 7 plus 5, 0. Underneath that, 3 plus 7 minus 10. Good. Right, so the next one I'm going to do this row with this column. So it's 5 minus 10 plus 5. And then 10 plus 5 again. That's what I wanted, 20 there. 15 minus 5 minus 10. Good. And then the next thing I'm going to do is this row, each of these rows with this column. 3 plus 2 minus 5. Good. Next one, 6 minus 6. 2 times 3 minus 1 minus 5. And then bottom row, 9 plus 1 plus 10 is 20. So that's good. That's what I wanted. Okay. There we go. 8. Express the set of 3 equations in matrix form as AX equals B. A is a 3 by 3 matrix and X and B are 3 by 1 column vectors. Solve the equations using the Gaussian elimination method and matrices. Okay, so to save space, I'll put this here. So you put the coefficients in here, 1, the X coefficients in this column, Y's in the next one, and Z in the next one. Then you put X, Y, Z next to this, and then what it equals 7, 0, 10. So for Gaussian elimination, what we do is rewrite this. I was trying to save a bit of time, but I couldn't see how to do it. Okay, and then put 7, 0, 10 next to it. And then we have to row reduce all the way down so we get 1, 0, 0, 0, 1, 1, 0, 1, 0, sorry, 0, 0, 1. And if we apply, and then what we get here, and there, and there, that's going to be our X answer, that will be our Y answer, and that's our Z answer. Okay. So the first thing we're going to do is the new row 2 is going to be the current row 2 minus 2 row 1, and then the new row 3 is going to be the current row 3 minus 3 row 1. Okay. Also, it's wise to do a little check by the side here of what these add up to. 1, 2, 3, 4, 11. That's up to 0. 3. That's up to 13. Because if we apply the row operations to the totals as well, that's what the transform row should add up to. If they do, it means we've probably got it right. There's a good chance we've got it right more. Unless, again, you've done 2 mistakes that cancel each other out. If they don't add up to the transform totals, then we've definitely got a mistake. Anyway, so top row stays as it is. Okay. So the next row, 2 minus 2 minus 1 minus 4, minus 1 minus 2, 0 minus 14, 0 minus 22. 2 minus 2 is 0, minus 1 minus 4, minus 1 minus 2, 0 minus 14. And then the next one is, then we've got to do 3. We've got to do this row minus 3 of each of these. Okay, so 3 minus 3 is 0. Minus 2 minus 6 is minus 8. 2 minus 3 minus 1. 10 minus 21 minus 11. Right, so now I'm going to apply these to these here, and then the new, add them up, and it should be these new answers. So I've got back to row, that's 11, and that should still add to 11 because we haven't done anything with this one. So here we've got row 2, take away 2 of these, so these should add up to minus 22. And do they? Minus 14 minus 8 is minus 22. And the next one is 13 minus 33 over here. 13 minus 33 is minus 20. Do these add up to minus 20? Yes, they do. Okay, so I'm pretty certain I've got those right. Okay, so what we're aiming for, we've got these two. That's in our first matrix transformation. The next thing we need to do is aim for a 0 there. Okay, and we've got a minus 8 there. So what we're going to do now is the new row 3. Actually, before I do that, let me just, I could do it here with a bit of fractions and stuff, but it would be a bit messy. The next thing to aim for is a 1 there. We've got that. We've got the 1, 0, 0 there, so that column's all right. The next thing to do is get the 1 in the middle. Okay, so we can say the new row 2 is going to be the current row 2 divided by minus 5. It's 1, 2, 1, 7, 0, 1, 0.6. Minus 3 divided by minus 5 is 0.6. Then minus 14 divided by minus 5 is 2.8. And this stays as it is at this stage. And so that's still going to be 11 because we haven't changed that row. That's still going to be minus 20. So if we do minus 22, this old total here, minus 22 divided by minus 5 is 4.4. And do these add up to 4.4? 1 plus 0.6 is 1.6, 2.6, 3.6, 4.4. Okay, I've got room here to do this. Under. I'll do it under here. So now we're going to say the new row 3 is going to be the current row 3 plus 8 row 2. So that's going to stay the same. 0, 1, 0.6, 2.8. So we say, so now we've got row 3 plus 8 of them, so that stays as a 0. Minus 8 plus 8 of them makes a 0 there. And then minus 1 plus 8 of them, we've got to put that there. So that's what I'm going to do now. So this is 0 plus 8 times 0 is 0. Minus 8 plus 8 times 1 is 0. So this last one is minus 1 plus 8 times 0.6. So it's minus 1 plus 4.8 because 6 8s are 48. So it's 3.8. And so this one is going to be minus 11 plus 8 times 2.8 plus, so 2.8 times 8, 8's are 64, 22.4 minus 11, 11.4. And if we've got this right, that one stayed as it is, that one stayed as it is, so it's this one. row 3 plus 8 row 2. So if we apply that to the old totals, minus 20 plus 8 times 4.4, so that's 32 minus 20 plus 32 plus 3.2. It's 35.2 minus 20 is 15.2. Does that add up to 15.2? 3.8, 11.4. Yes, so it's very likely to be right. Okay, so I'm quite happy with that there. Okay, and then the last thing that we're going to do here, so I've got a note there, is now I said before we wanted a note there and there. We actually don't need to go that far. We can work it out once we've got ones on the leading diagonal. I'll show you how in a minute. So now I'm going to do the new row 4. It's going to become the current row 4 divided by 3.8. 1, 2, 1, 7, 0, 1, 0.6, 2.8, 0, 0, 1. 11.4 divided by 3.8. Same as 38 into 114. That's got a ring of 3 about it. 3 8s are 24. Yeah, 113. So that's going to be 3. And then 15.2 is going to be 4. Which is right. 15.2 divided by 3.8 is 4. And 1 plus 3 is 4. So I'm happy there. Okay, now we could go on and find zeros in these other places, as I said up there, but actually we've got enough information here. So row 3 here, this gives us that z is 3, because that's the z. And then row 2, this gives us y plus 0.6 z is 2.8. So z equals 3, that first one. That's very neat there actually. So we've used that, that's the z equals 3. Now we're going on to this row, that's row 2. So therefore y plus 0.6 times 3 is 2.8. And 0.6 times 3 is 1.8. So therefore y is 1. And then from row 1, we've got x plus 2y plus 1z is 7. So therefore x plus 2 plus 3 is 7. So therefore x is 2. And all these we can check by putting in the original equation, in the original equations. So the answer, x is 2, y is 1, z is 3. So let's run them in here. So this is 2 plus 2 1s is 2, so 2 plus 2 is 4. Yeah, that worked the work for the first one. Just do quick mental arithmetic. 4 minus 1 is 3, minus 3 is 0. 6 minus 2 is 4, plus 6 is 10. Okay, I'm very happy that that's my answer. I'm completely convinced that's my answer. I'll just colour that in as well for completeness. Right, number 9. Got 2 questions left. Number 9. Express the set of 3 equations in matrix form as AX equals B. A is a 3 by 3 matrix, X and B are 3 by 1. Then use row reduction simultaneously. Solve for X, Y and Z and find the inverse matrix A minus 1. This could be quite a long method actually. Just trying to think. I'll do the long method. So to simultaneously and find the inverse matrix A minus 1. So the way that we do this is 1, 1, minus 2, 3, minus 1, 1, 1, minus 2, 1. Like we did before, but because we actually want the inverse, we also put, we row reduce the identity matrix as well. And then we've got the minus 2, 12, 7. And then we've also got the totals at the end. So we've got 1 and 1 is minus 2 is 0. 1 minus 2 minus 1 is that total. 3, 2, 3, 4, 16. And the last one adds up to 8. So basically, so like I said before, this we're actually going to row reduce to what the full thing here. And then by performing those row reductions on these coefficients here, performing them on there will give us the inverse, and performing them there will get us the answers as well. Okay, so we're going to end up with something there. We're going to end up with a 3 by 3 there. And we're going to, okay, so that's A. When we finished, sorry, we start with A there. We end up with the identity there, and A inverse, and then the answers there. Right. Okay, so row 2 becomes the old row 2 minus 3 row 1. They're not the same as the previous one, no. And then the new row 3 is the current row 3 minus row 1. That's all I can do there. And row 1 stays as it is. And I'll just put these in here like this. I'll put the total in here in blue because otherwise it's too fiddly, it's taking so much time. Row 2 minus 3, 0, minus 1, minus 3, minus 4. 1 minus 6 is 7. 0 minus 3, minus 3. 1 minus 0 is 1. 0 minus 0 is 0. 12. Minus 6 is 18. The totals column. 16 minus 3 is 19. Do these add up to 19? Does this row add up to 19? Minus 4 plus 7 is 3. Minus 3 is 0, 1. Yes, it does. And then this one, 1 minus 1, 0. Minus 2 minus 1 minus 3. 1 minus 2 plus 3. 0 minus 1. 0 minus 0. 1 minus 0. 7. I don't know these right. 1 minus 1. Yes. And this is 7 minus 2, which is 9. And the totals is 8 minus 1, which is 9. Does that bottom add up to 9? Minus 3 plus 3 is 0. Yes. Right. So the next thing I'm going to do is the new row 2 is going to be the old row 2 divided by 4. 1, 1, minus 2. 1, 0, 0. Minus 2. Minus 1. We haven't changed that one. Divide this by, minus 4 even. 0, 1, minus 1.75. 0.75. Minus 0.25, 0. Minus 4.5, minus 4.75. Do they add up to minus 4.75? Yes, they do. And the last one. What you can do for this one, you can say the new row 3 is the old row 3 plus 3 times the new row 2. Okay, because look, then that's going to put the 0 there that we want from up there, look. Okay, so 0 plus 0, minus 3 plus 3. Oh gosh, calculator time. It's just getting a little bit complicated. 3 plus 3 times minus 1.75, so it's 3 plus 3 times minus 1 plus 3 times minus 0.75. So it's 3 minus 3. That's going to be minus 2.25. This next one is going to be minus 1 plus 2.25. That's going to be 1.25. 0. That's going to be minus 0.75. That's going to be just 1. That's going to be 9 plus 3 of them is minus 4.5. 9 plus 3 of them. So we've got 9 minus 12 minus 2.25, so it's minus 5.25. They add up to minus 5.25. Minus 6.75. Sorry. Minus 1 plus 1. Yes, they do. Brilliant. Right. I quickly need a calculator. If I get one on here. Oh, I'll try and see if I can do it again. Right, so the new row 3 now is going to be the old row 3 divided by minus 2.25. By the way, I would never put one of these in the exam. Never mind you suffering, it'd be me marking. Can you imagine marking this? Good Lord. But I definitely would not. So don't worry, but this is just for your maths knowledge. This is for the love of maths, this one is. That one's going to stay the same as it is. Naught, naught. Right, so that's going to be 1 there. So the next one I've got 1.25 divided by minus 2.25. So that's going to be 125 over minus 225. 5/9. Minus, I'm moving to fractions because they're easier for me to do. What's this one? So this is what is it? Row 3 minus 0.75 divided by minus 2.25. So it's 75 over 225. Now I know this will go into there, but it's 1/3. But I'm going to write that as 3/9. That one's going to be naught, only because I'm going to keep them all in 9ths because I think that's going to be easier. The next one is minus 4.5 divided by that, which is plus 2. And minus 5.25. Minus 5.25 divided by minus 2.25. So it's 525 over 225. So that's going to be 26 over 9. Do these add up to 26 over 9? That's 9 over 9, 12 over 9. And the 2 is 18 over 9, so it's 30 over 9. 12. It's not quite right. 20. Sorry, that's 25. Just got to check my arithmetic on this bottom row again. One of them I think's gone wrong somewhere. So it's divided by minus 2.25. 1.25 divided by minus 2.25. 5 over 9. Agreed. Agreed. Oh, I've done, it's this one. Look, I've done, no, it's 1 divided by minus 2.25. So that's 100 divided by 225. Do this on a calculator. So it's going to be 4 divided by 25 divided by 25, 4/9. There we go. If anybody's still listening, 4/9. Right, so we've got 9/9, 4/9, 8/9, 11/9. 9 plus 3 plus 4 plus 18, 12, 34. So the negatives become positives, positives become negatives. That should be minus there. 1, 9, 12, 13, minus 21. 4, so 20. Yeah, it's right now. I've got it right now. Hallelujah. Okay. Right, I definitely won't put this in an exam. Right, so the next one, I'm going to change I'm going to change the second row to fractions. So 1 3/4 is 7/4. That's a 1. That's 1 3/4. This is going to be 0, minus a quarter, 3/9. 0, 0, minus 4/9, minus 2, minus 9/2, 2, minus 1. That's 16, 17, 18, 19. Minus 4, minus 5. Minus 8, minus 5. Did I actually check that one before? Minus plus 3/4, minus a quarter. I'm going to stop now because I can't see what's happened here. Oh, it is right because that 1 is 4/4. Right, that's so they cancel. Yeah, that's it. Right, ready to go again. Not going to stop. Right, next page. Let's insert another page. Keep going. Actually, it's a little bit spaced at the bottom. Right, so row 2 star now becomes the old row 2 plus 7/4 times row 3. And that's going to give us a 0 there. So the row 1's going to leave, well, actually I'll probably do row 1 in a minute, so let's just leave this one. Row 3 is going to stay as it is. Right, so this one is this row plus 7/4 of this one. So that's going to be a 0. That's going to be stays 4/4. That's going to become a 0. So the next one, I'll just do this working out in the side again. So we've got, it's going to be 3/4 plus 7/4 times minus 5/9. So it's 3/4 minus 35/36. So it's 27/36. Minus 35/36 is minus 8/36. Okay, so the next one is going to be minus a quarter plus 7/4 times 3/9. This is minus a quarter plus 21/36. Minus 9/36 is 21/36. So that's going to be 12/36. Okay, you can do all this on your calculator, I just haven't got one to hand. The next one is going to be 0 plus 7 over 4 times minus 4 over 9. So that's minus 28 over 36. Okay, and the next one is going to be minus 9 over 2 plus 7 over 4 times 18 over 9. So it's minus 9 over 2 plus 70 and 56, 126 I think, over 36. Minus 9 over 2. Let's 6, 9 times 18, 72. Minus 162 plus 126 over 36. 26, 36, 46, 56, 36. Minus 1. And the addition one, and I really hope this is right. The addition one. So I've got minus 19 over 4 plus 7 over 4 times 21 over 9. Minus 19 over 4 plus 147 over 36. 19 times 9, 81. You can do this on your calculators, don't worry about what I'm doing here. Minus 171 over 4 plus 147 over 36. Oh, that's over 36 now, because I multiplied top and bottom by 9. 24, minus 24 over 36. So I've just got to check that that row adds up to minus 24 over 36. So I've got 36 over 36 minus 8 plus 12 minus 28 minus 36 minus 24. So 36, 48. Sorry, I don't want that, that's what it's got to be equals to. So 48 minus 8 minus 28 minus 36. So it's 48. That's minus 36 minus 72, which is minus 24. Amazing. Whew. Calculator is your friend for these. And then the last thing, I'm going to actually do the new row 1 here. It's going to be the old row 1 plus 2 of the new row 3. Okay, so what we've got here, look, 1 plus 2 of them, 1 plus 2 of them, minus 2 plus 2 of them, and then all the rest with the fractions over here. So that stays as a 1, that stays as a 1, and that's going to become a 0. So then we've got 1 minus 10 ninths, so it's 9 ninths minus 10 ninths minus a ninth. 0 plus 6 ninths, 6 ninths. 0 minus 8 ninths. Minus 2 plus 36 ninths is minus 18 ninths. Plus 36 ninths, so it's minus 18 over 9 plus 36 over 9 is 18 over 9. And this last one is minus 1 plus 42 over 9. That's minus 9 over 9 plus 42 over 9 is minus 33 over 9. Do they add up to minus 33? So we get 9 plus 9 minus 1 plus 6 minus 8 minus 2 minus 8 minus 18 plus 18, just check that one. Minus 9 over 9 plus 42 over 9 is plus 33. They need to add up to 9, 18, 36, 42 minus 9. Yeah, that one's right. Good. Okay. And then finally, gosh, this would not be in an exam. The final thing here, the new row 1 is going to become, see if you look here, what we've got 1, 0, 0, 1 there. That's actually a 1 and a 0 there, a 0 there. We're going to get a 0 there now by doing this row, take away this row. Okay, so we worked around it. We made a 1, 0, 0, 0, 1. We've also made that into 1. So start again. 1, 0, 0, 1, 0, 1. And then you can use this row to get a 0 there. And then you can use this row and to get a 0 there and a 0 there. And then we can use this row to get a 0 here. So it's row 1, the new row 1. This is the final step we need to do. It's going to become the current row 1, take away the new row 2. Okay, well, it's the row 2 that we've got. So we're going to use this one here. This row here, this new row 1 is going to be this one. Take away this one, because then we're going to get a 0 there. That's 1 take away 0, 1 take away 1, 0 take away 0. Right. Okay, so row 2 are all in 36. Okay, so I've got to multiply each of, I'm going to make multiply. Right. Row 1 minus row 2. So look, this here minus a 9th is actually minus 4/36. Okay, 6/9 is actually 24/36. I'm making them on 36 so it's easier to work out. 6 over 9, yeah. Minus 8 over 9 is minus 32 over 36. 18 over 9 multiplied top and bottom by 4, 72 over 36. And 33 over 9, 33 times 4 is 132. So it's 132 out of 36. I've just done that because I'm doing these fractions in my head, but you wouldn't need to do it if you're using a calculator. So this is going to make this easier now. So I've got to do row 1 minus row 2. So it's that minus that for each of these. It's going to be a lot easier now they're all in the same denominator. So for 36, minus 4, minus 8, 4/36, 24 minus 12, minus 32 minus 28, 72 minus 36, and 132 minus 24, 156/36. So we've got 36, 40, 52. Yeah, they had it correctly. 0, 1, 0. Do you know what? I just cannot believe it. I think I've actually got to the end. Minus 28/36, minus 36/36, minus 24/36. 0, 1. Right, these are making to 36 as well. This is minus 20 over 36, 12 over 36, minus 16 over 36, 72 over 36. The last one, 84 over 36. So 36, 48, 28, 12. Yeah. Right, this last row here, this was just my running totals. So I don't need that as part of the final solution. Okay. But here, The bit that I'm going to highlight now, no, that's not a highlight, that's a rubber. This bit here, in here, this bit here, this is the inverse. Okay, that's the inverse matrix, and this bit here is the final solution. So I'm just going to go onto the other side. So the inverse matrix is, there's another one on the other side. The inverse matrix is the pink, and then the X, Y, Z are the yellow. So I'm going to put this in the margin, just to. I'll do it in a different colour. I'll do it in a nice bright colour so you can see it. I'll do it in red. Right. So the answer after all this. Right, so the inverse matrix, now the reason you'll see now I turned them all into 36 at the end, your calculator would have done this for you anyway. It's going to be 1 over 36, 4 minus 8 minus 20, 12, 12, 12, minus 4, minus 28, minus 16. You could also take a 4 out there as well, so that's going to be 1/9. 1 minus 2 minus 5, 3, 3, 3, minus 1 minus 7 minus 4. So that's the inverse matrix. And the answer, X is 108 over 36, which is 3. Y is minus 36 over 36, which is minus 1. And Z is 72 over 36, which is 2. Okay, so that's where I got the X from, that's where I got the Y from, and that's where I got the Z from. And that will do for that one. Right, sorry about that. Well, not sorry, it's just what it is, but it wouldn't be in an exam. Right, number 10. This one would be in an exam because it's a nice question. Find the eigenvalues and corresponding eigenvectors of the following matrix. So what we have here is, the eigenvalues are 2 minus lambda, 3, 3, 2 minus lambda. The eigenvalues are those values lambda that make this determinant equal 0. So this is 2 minus lambda times 2 minus lambda minus 3 times 3. If we do 2 minus lambda times 2 minus lambda, it's 4, minus 2 lambda, minus 2 lambda, plus lambda squared, minus 4 lambda, plus 4, minus 9. This is lambda squared, minus 4 lambda, minus 5. That's going to be lambda minus 5, lambda plus 1. So our eigenvalues, well, our eigenvalues are where this equals 0. So it means that this is 0. So this is 0. This is 0. This is 0. So lambda is plus 5, or lambda is minus 1. Okay, so let's do the first one. Lambda equals 5. So we put 5 here. And what we say is 2 minus lambda minus 3, 3, 3, 2 minus lambda minus 3 times xy equals 0, 0. Okay, so minus 3x plus 3y is 0. So therefore, right, both equations will give the same thing. And if you look, you're going to have 3x minus 3y is 0 for the next one. Got that times that. That's what I've got there. That's all those bits. The other equation, multiplying out the other one, will give us exactly the same thing, so I'm not going to do it now. This means that 3y is 3x. So this means that y equals x. Okay. So what we have here is the eigenvalue. Lambda is 5. Gives us eigenvectors. Y is x, so they've got to be the same, and it's alpha, like so. Okay, now next one, lambda is -1. And so we've got 2 minus -1, which is 3, and that's 3, that's 3, and that other corner is 2 minus -1, which is 3. X, Y is 0, 0. So we have 3x plus 3y is 0, so therefore 3y is minus 3x. So this means that y is minus x. So our eigenvalue lambda is -1 has eigenvectors. Y is minus the x. Okay, that's our answers there. So that's that bit there, that's there, that is that. Right, so the eigenvalues of the matrix A squared, 2, 3, 3, 2. So this is the A squared. There is a quick way of doing this. I've got that the right way around, yes I have. Oh, let's do A squared first of all, but you'll see it. I'll do it once, then you'll see it. Right, so this is 2 times 2 plus 3 times 3. 3 times 2 plus 2 times 3. 2 times 3 plus 3 times 2. 3 times 3 plus 2 times 2. So it's 4 plus 9, 6 plus 6, 6 plus 6, 9 plus 4. So the determinant of 13 minus lambda 12, 13 minus lambda there equals 0. Okay, if we multiply out 13 minus lambda, we get lambda squared minus 26 lambda plus 169 minus 144 equals 0. Lambda squared minus 26 lambda plus 25 equals 0. This is going to be lambda minus 25 lambda minus 1. Okay, equals 0. So we've got lambda is 25 and lambda is 1. If you compare what I did then, compare with the other one, the eigenvalues of I were 5 and minus 1. The eigenvalues of A squared is 5 squared, 25, and minus 1 squared, which is 1. So just so so you can see that there. So we didn't really need to do that step, but I've done it once. Right, substituting here, 13 minus 5 minus 12, 12, 12. Okay, let's get minus 12x plus 12y is 0. So 12y is 12x, so y is equals to x. So they've got eigenvalues 1, 1, same as before, look for the 5. So it's the same eigenvector and it's lambda squared for the other one there. Then our next one, lambda is 1. 12, 12, 12, 12. X, y is not. 12x plus 12y is 0. So 12y is minus 12x. So the eigenvector is minus 1, 1. The previous one, look, it doesn't matter that I've put this one as the negative at the top, because with the beta you can just say, or it's beta 1 minus 1. Okay, what you see there, you could either have 12x is minus 12y. It doesn't really matter which way around you do those at all. That concludes that.